Hello everyone. So today I wish to show you a project I work on recently, and this is a project of infusion pump. Special thing about this pump is that it's Wi-Fi enabled and also highly programmable. Motivation behind this project is establishing heat for chemical synthesis in continuous flow. First I will start with showing you how this pump works. Then I will show how it's built, and at the end I will explain a bit about problems that I approached during development. So let's see. So if you wish to operate, you need to start with homing. So pump automatically finds its starting position. Then when this is finished, you can draw liquid with pump. So set position to maximum. This value is actually just set for this particular syringe, but it also allows for operation in this case. And then you can set here how much volume you wish to push and also with what speed. So let's lower speed to 20 milliliters per minute. And then you can press run. Then you can repeat it until you spend all liquid from your syringe. Now let's talk how it's built. So most significant part is here. This is a linear rail with lead screw that is moved by stepper motor. On movable stage we have structure that holds plug of syringe held in another 3D printed part. This 3D printed part also has end stop for detection of collision with end of range. Then on electrical part we have ESP32 that controls stepper motor driver TMC 2208. So on programming side I have code written in Arduino IDE. From interesting features is that pumping action doesn't block whole program, which may be handy in further development. And other interesting parts are going in Node-RED. So what's going on here actually? ESP32 is connecting to Raspberry Pi through Wi-Fi. Raspberry Pi runs Node-RED with Mosquito as MQTT broker. And here we have code in Node-RED that basically creates whole user interface and makes calculations. Interesting calculations are going here. So basically by inserting syringe diameter you can calculate what's the volume of a single step, how many steps are done per second, and what's the volume pumped per second in different units, so you don't have to calculate it in memory. Also it gives you information on how much liquid will be pushed out of single syringe. There are some also more technical sliders which can be handy in some situations, but for ordinary users most important is desired volume and desired volumetric speed, and of course run button. Let's talk now about problems I faced during development. After getting conception what I actually want to do and how it's supposed to look like, I went with buying this kind of rail which already have a stepper motor with driver. But unfortunately vendor wasn't able to tell me what this stepper motor is. So I took a risk and bought it. Unfortunately, one rail was destroyed in this way. Because I didn't knew what is it, I couldn't provide proper current and set this system correctly. And I have now one completely destroyed system. But at least this allowed me to learn what's the exact structure of this motor, together with how this lead screw is attached to motor. Unfortunately, it's significant part of internals of this motor, so I cannot really reuse it, but still I can remove it, remove this lead screw and use a moving stage for some other purpose. Then I moved to stepper motor driver that I just took away from another old 3D printer I have. After I had the programming done, I decided to move to mechanical parts that hold syringe. And this part holds syringe, this one pushes plug. So there were some problems. This one, although it was successful in holding syringe itself, it was very awkward to insert syringe from the front. Next iteration I decided to go with this system where syringe basically snaps from the side. This is big quality of life improvement. Also I added this part that holds syringe in place, so it has no chance to move back and forth. If it comes to part that pushes plug on this moving stage, here problem was that it wasn't tight enough and it was moving a lot. Therefore backlash was large and the repeatability in this case would be very low. This problem was addressed in next iteration, but unfortunately due to poor measurements I had to a bit melt plastic to be able to force it on a stage and also to be able to mount it with screws. So next iteration eliminated these problems, but another thing became apparent. First of all, quality of print is bad because of how it was printed. It was printed in this position. And the other thing is that also here, those mountings which holds plug while retracting, it wasn't strong enough. So those problems were addressed in next iteration, where here those parts are much thicker and also it was printed in different orientation. Now quality of print is much higher. So what next with this project? First of all, I want to assemble this electronic part into something more mechanically resistant. So I just want to solder everything together. Then I will assemble second pump, well, in an identical way, so I can start working on a system of pumps. And then I will, of course, build software that will coordinate all pumps connected. Well, so that's it from my side. I'm glad to hear your feedback, suggestions and ideas. And well, hopefully see you next time.